In this video, I want to talk about assembly drawings and part drawings. Now, as we know that for steel structures, COMOSYS has the capability of producing assembly drawings and part drawings automatically. And for that, the procedure is very simple. We just select any assembly, for example, or select a part, and we right click and we go to create drawings, and then we ask the program to create the part drawing or the assembly drawing. So actually how to create the drawing is very simple, but the thing which is a little more involved is how should it create those assembly drawings or part drawings, and what should be the settings which it should use. So in the drawings and reports menu, once again, like I said, we can right click and create the drawing as well, but we can also just go to the create drawings menu over here, tab over here, and we have various options of creating assembly drawings and part drawings and formwork drawings and rebar drawings and joint reaction drawings. But we're going to be talking about primarily the assembly drawings and part drawings right now. But like I said, when we press this button to create the drawing, it creates the drawing according to certain settings. And those settings are right next to this button over here. This button is called Drawing Settings. And inside, we have all these options of the settings for assembly drawings, setting for part drawings, formwork drawings, etc. So I'm going to be talking about these settings in this video because they are a bit involved and you need to understand them so that you can customize the drawing creation process according to the needs of your company. So let's start off with the drawing settings for assembly drawings. And obviously we need to have the settings ready before we create the drawings. So let's just dive into that. When we press that button, this dialog box appears, and I'm going to go through the various tabs of this dialog box so that you understand all of them. And finally, I'm going to come back to this multiple settings tab, which needs to be explained at the very end. So let's start with the general tab. And in the general tab, what we have is a drawing title, a drawing name prefix. This is it's like a number, drawing number prefix rather. So you can give your drawing a title over here. You can write anything you want. It can be like beam details or anything you want, basically. And obviously, all drawings in the steel detailing industry or concrete detailing industry, they have drawing numbers, and those drawing numbers. This is like a prefix. So if you're drawing, so you can have any kind of a prefix. It can be a long prefix, and finally the numbers will go. Let's say you're producing. Let's say you select all the columns and you produce your drawings. Let's say there are 20 drawings. So it would go like 835-156-CE-001-002-003-004-005. It's just going to keep going until it gets to the end of the list. So you can have this long prefix and you can modify it any way you want. It's basically just a text which is used. Your company might have its own format of maybe a project code and discipline code or type of drawing or something like that. But finally, a prefix is going to be added to that, and that prefix is going to start from 1. So when you're creating drawings, you can make them start from 1 or from 100 or from 1,000 or whatever you want. It's just going to go and add to that drawing number. Now, the next field over here is the page size, and this is actually a starting page size, if you will, because when you create drawings, you're trying to fit in that assembly or that part in a certain on a certain paper size. And what might happen is that you might have, for example, A3 over here, and it might start to fit in that assembly into that A3, but it might not fit. So A3 will be the starting page size, and what will come later will depend on what we will discuss in the layout section in a bit. So consider this to be your starting page size, and you can fix it as well by using some options in the layout. But normally, what will happen in steel assembly drawings is that you start off with a certain page size, and then you can keep increasing the pages according to your settings in your layout. The next option is whether you want the default orientation to be landscape or portrait. That's pretty obvious. The next thing over here is also pretty obvious, but I just want to say that in your assembly drawings, you will have a scale for the assembly drawings, and you can enter the scale which you want over here. And within the same assembly drawings, we have this option of including single parts or not. So there are two ways people create drawings. One is that they will create an assembly drawing with an assembly, and only the assembly will be and the parts on it, the location of the parts on the assembly will be dimensioned, obviously, but the individual single part drawings will not be put on the same assembly drawing. Those will be created separately as a separate folder. So these are obviously options. You can include your single parts in the same assembly drawing or not, but let's say you choose to do so. Let's say you want to include the single part drawings of every single part on that assembly within that assembly drawing. In that case, you will also need to provide these two scales over here. One is for the profile part scales, and one is for plate part scales. So your individual single parts might be profiles themselves, or they could be plates, and depending on whatever they are, you can have different scales for them. Now, the next variable over here we can talk about is this save and close drawings and freeze drawings. This is basically just a behavioral directive which you can give the program, that because when you will be creating drawings, you will be creating, or you can create multiple drawings at the same time. So let's say you create 100 drawings of beams and columns or whatever. And at the end, while it's going to create, after creating each and every drawing, you want it to save that drawing and close that drawing. You don't want to keep them open. Or you could just leave this on off, or you can have them all open at the end. And whether you want the drawings to be frozen once they are created, and we'll talk about what it means to freeze a drawing in a minute. The next thing we'd already talked about, which means the inclusion of single parts. That's an option which you can have on or off. And this is draw single assemblies in each drawing. What that means is that, once again, there are two ways of creating assembly drawings, what we call single assembly drawings or multi-assembly drawings. So what you can have is, let's say you have an A0 size paper in which you're creating the drawings of your purlins. Now, purlins are pretty simple elements, and you can have maybe 25-30 different purlin assemblies in the same A0 drawing. So that's what we call a multi drawing, in which you have multiple assemblies in the same drawing. But another style is that you use one page for each assembly, and then you move on to the next page for the next assembly. So in that case, you will have perhaps lots of A4 or A3 sized drawings for your purlins, one for each. So depending whether you want to draw a single assembly in each drawing or not, you will select this tab, this flag. You will check this. Now over here we have the alternative drawing name prefix. So we had talked about a prefix, but in some projects we have multiple drawing numbers, depending on, sometimes the client has a different drawing numbering method, and you have a different method, and you want to have both of them. So you have this option of having an alternative drawing numbering method. So it'll give two numbers to each drawing. Obviously, the starting value will need to be, the series will need to be the same, and they'll get the same prefixes, the suffixes at the end. But the prefixes can be different, and that's optional. You don't have to do that. This part over here you won't be using most of the time, but I'll just explain it. That it's called it's to do with the collapsing of elements. Now, what is collapse? So imagine a long purlin, say 6 meters long or 8 meters long, and it's just got two holes at the ends, two bolt holes on the left end and two bolt holes on the right end, and there's nothing in between. So when you draw that, and on a scale of 1 to 10, it's gonna so it's 800 centimeters, and on a scale of 1 to 10, it's going to become say 80 centimeters. So it's going to be the size of almost an A0 page. And there's going to be nothing on it, basically. It's just going to be one big line, and it's going to be taking up a lot of space. So for that, what we have this option of collapsing. And what collapsing means is that when you're going from left to right, if you don't see any activity on that assembly for a certain amount of time, you collapse that area into a much smaller area. So if you want your collapsing to happen, you will turn on these flags. So you can collapse the assembly drawings, you can collapse the profile part drawings, and you can collapse the plate part drawings. Or you might decide not to do so. So depending on whatever you won't need to play around with these numbers, but you can. But the basic thing what you need to know is whether you want to collapse or not. And by default, normally having the collapse on is a good idea, because you in Steel you do have lots of members with something at the start and something at the end, but nothing in between, and they unnecessarily take up a lot of space. Now let's move on to the views tab, and in 99% of the cases you won't be needing to touch any of this, but I just need to explain a few things. And that is, so this is to do with the views which will be created in the drawings for the assemblies and for the single parts. And you've got control over every single view which can possibly or potentially be created. Obviously, it will depend on whether the view needs to be created, but you can force certain views to be created as well. So when it comes to assemblies, you have a main view look direction. Now, what that means is that obviously an assembly can be oriented in any way. You can have an I-beam as the main part of an assembly, but it could be you could be looking at it from the flange side, or you could be looking at it from the web side, or if it's a truss, the top and bottom chords might be rotated in such a way that you might want to change the default look direction, because you want the main view of the truss to be the way we normally look at a truss from the front. But that front look might in certain, depending on your top chord and bottom chord, might be the y-axis of that top chord, or it might be the z-axis of that top chord, depending on the orientation. So you can change this main view look direction if you want, and you can decide whether the assembly's main view will be looking from the positive y of the main part, or the negative y of the main part, or the positive z, or the negative z. Obviously, you can't look at the main view from the x direction, which is the cross-sectional view. But these four options of the y and z sides are available for you. And like I said, once again, more often than not, the program will do this automatically. If you want to change it, for some cases you can change it. And then once you've selected the main look direction, then you still have this option of creating the top view, the bottom view, the front view, the left view, the right view, and you can turn them on and off. But once again, you will not be touching these more often than not. Only in special situations you might want to modify them. And for the single parts, again, a single part can be a profile, or it could be a plate, or it could be a generic solid. And in all these cases, you have control over which views, the top view or the bottom view, front view, left view, right view, which particular ones you want to create or not create. So this is like a summary of this. These are just margins over here for the page, which you can enter, and interview port distances as well. So when it's because a drawing will be composed of many viewports, as we already know, and the viewports should be as close to each other as they can, because you want to fit in as much as you can. So you can modify these numbers depending on how closely fitted you want the viewports to be. Now, these two are important, and I'm going to just explain what they do, and then in a separate video, perhaps I'm going to show exactly what they do. But in principle, you should know what they are. So this is keep manual changes, and this is called create auto revision clouds. Now, what we mean by keep manual changes is that although in COMOSYS the drawings are very clean, as you've already seen in lots of other videos as well, but there could be situations where you want to manually do some cleaning up for a particular assembly, let's say, and you want to move certain annotations around, you want to give extra dimensions maybe, or you want to delete certain things or something of that sort. You want to modify the location of the annotation prime. Those are the things which are typically done to clean up drawings. Now, when you've cleaned up a drawing and then something happens to that assembly, so let's say you're talking about a truss assembly, and you have, although truss assemblies are very clean in COMOSYS, but just for the sake of giving an example, let's say you have a truss assembly and you've done some manual cleaning up. You've moved some annotations left and right, you've moved some dimensions, you've added a note or something like that. Now, this is an automatically generated drawing, which now you have done something manual. You've made some manual additions to it. Now, normally what would happen is that when, let's say you were then to add something to this assembly. So let's say you added a plate, you welded a new plate to the truss, and you did the numbering again, and you now obviously you need to recreate the drawing once more. And when you recreate the drawing, the truss or the assembly drawing creation macro is going to run again. And what that will do is obviously it's going to delete the previous drawing and basically make it from scratch, because you could have made any modification, any kind of modification. Now, what we want is that when the macro runs again, we want ideally for it to keep the changes which we made manually. So we might have moved, like I said, moved some annotations around, moved some dimensions around, maybe added a note or two, or done something manually basically with it. And whatever we've done, we don't want the macro to destroy it the next time the revised drawing is created. So if we, and by default this is on, so if you turn this on, this is what's going to happen. Even if the macro runs again, whatever, if you've done any manual changes to it, those manual changes will be retained. So that's the meaning of keep manual changes. And the creation of auto revision clouds is basically, obviously, when there's a change in the assembly drawing, some dimensions have changed, some annotations have changed maybe, or some numbers have changed or that sort. You want them to be, you want a cloud around them, and you want to see exactly what happened. What is the difference from the previous drawing to the new drawing? So these two are for those very important purposes. Keeping your manual changes is very important, although, like I said, in COMOSYS, more often than not, you will like what you will see, and this is exactly what you want. You don't want to spend too much time on manually cleaning up drawings. You want to press the generate drawing buttons and then kind of be okay with it. So that's what you would normally do. But let's say it's a very complicated assembly and you have made some changes. Now in this case, you want your changes to be maintained every time the assembly drawing needs to be recreated. Now let's move on to the dimensions tab. And over here also, most of the stuff over here you will not be dealing with. I'm just going to mention some of the important ones. So over here we have these create left right dimensions for profiles and for plates, and also create above below dimensions for profiles and for plates. Now, if you think of a plate and it's going to have holes inside it. Now, typical dimensioning of the plate will be there'll be a dimension line at the top, a dimension line at the bottom, a dimension line on the left, and a dimension line on the right. And you can choose to have, so for example, if you're talking about a plate, you can choose to have both the left right ones and both the top bottom ones. Or you can say I only want the right one and the above one. And in this case, it will collect all the points which need to be dimensioned on the right hand side and on the top dimension. You can leave it at default and it'll do a good job depending on the situation of the plate. But you can modify these parameters for plates and bolts. But more importantly, over here, we have these options of dimension by parts or dimension by bolts, or dimension by both. So if you turn both of them on, you can dimension by parts or by bolts as well. But what it means is that, so in an assembly, let's imagine an assembly over here, a main beam on which there is a gusset plate which is welded. And obviously the purpose of an assembly drawing is to show the exact location of this gusset plate on the assembly. Now there are two ways of dimensioning this. One could be dimension by parts, in which case it would take any of the edges of the gusset plate, one or two edges, and dimension them to the main beam. So it will say that the gusset plate starts at 3000 and ends at 3, whatever, some number. The other way of now this is obviously possible, but another way would be that if that gusset plate had any holes in it, then instead of giving the giving the dimension of the edge of the gusset plate, it will give the dimension of the first bolt and the second bolt, let's say, of the gusset plate. Now you might think that they're basically both the same thing, but in steel detailing, parts are usually cut at a tolerance, and there can be mistakes, say about 1 millimeter or something like that. And you don't want, so if the part has been cut slightly shorter, for example, and you were to dimension by parts, then they would put, let's say it was supposed to be 3000 millimeters from the left, but the part has been cut short, so it is positioned at 3000, but now the holes inside inside that plate are not exactly where they should be, and now the part which is connecting to this assembly might have a problem. So another reason could be that these rolled profiles which are sold in the market, they're sold with certain tolerances. And so the height of an IPE 300 beam, when you actually go and buy it, might not necessarily be 300. It could be 299 or 298.5. And so what you want actually is, the preferred way in steel is actually to dimension by bolts, because any tolerance mistake which you might have will be removed if the guys when they're looking at the final assembly, which has problems, and they actually locate that plate according to the bolts rather than the parts. And if that happens, then any 1 or 2 millimeter differences will be adjusted, because the bolts will at least be in the right place where they need to be. So a good practice is to have dimension by bolts to be the default one. You can choose both, or you can choose one of them depending on what you want. This one over here, remove levels at flange and web thicknesses. Normally when you have rolled profiles, you don't want the rolled profiles web thicknesses or flange thicknesses to be dimensioned, because they're rolled profiles anyway. You just buy them off the market, you don't manufacture them. But if you have a built-up profile with or a plate girder, then you want those flange levels and web thicknesses, etc., to be dimensioned as well. So you can turn this on and off depending on what kind of an assembly that is. This is including the main part internal dimensions. Normally, when what it will do, if you turn this on, then it will not draw the single part of the main part separately, but it will just dimension the main part in the main assembly section of the drawing. But if you turn this on, then even the main part of the assembly will be drawn separately as a single part as well. Next, we have the annotation and display settings. Now, if in an assembly, I'm just going to open an assembly in a bit, so you will see exactly what I'm talking about in all of these tabs. But in an assembly, obviously, you have your frames, you have your plates, you have your bolts, you have your welds, and you have your dimensions, and they need to be drawn in a certain way. So, for example, if I turn on the frame settings and I go to the display button over here, over here we have the options of what the line thicknesses and the colors and the line styles and whether the definition lines will be drawn or not, and all these parameters basically you can save away in the settings over here. Similarly, for the plates also, you have the display settings of the line thicknesses and things like that. Basically, how the drawing will look, how the annotations, etc., and how the drawings of the plates themselves will look. Similarly, for the bolts, you can have different thicknesses, line thicknesses, and also for the welds, you have the same thicknesses. For the dimensions also, you have the properties of the dimension. So whether you want to, what precision do you want, what dimensioning style you want, what fonts you want, what the size of the fonts should be, what the size of the arrows or these lines should be, what the distance from the object, all those things you can set over here and then create your drawing accordingly. when it comes to the fields, so for example, if there's a frame or there's a plate, what fields should be how should the annotation be? So for example, it says for the plates, show the actual part number, and for the frames it says show the single profile name as well as the actual part number. So you can set up what exactly the annotations will look like over here. So for the bolt settings, you can go inside and say for the bolts I want to see the diameter and the length, and you can actually go inside and change the line thicknesses and the colors and the size of the fonts, etc. So all those for the wells as well, you can choose how the well how the well will be shown, the font size and everything. For the dimensions also I just talked about. So all these are basically to do with how the annotations and the frames and the plates themselves will look on the drawing. The size of the font, the color, the line styles, which particular fields will be shown. Those are all governed from this annotation and display settings tab. And over here, you have basically your barrier settings, and you don't need to play around with them, but you can. This is to say, because in COMOSYS, everything finds its own place. Nothing is left clashing. So you can choose what barriers are allowed and what barriers are not allowed to. So if it's looking for a place for the annotation of a frame, it's going to try to find a place near that, and it's going to come over other things, and you can allow or not allow what other things it's allowed to come over. So all these are barriers which you can set, and I don't need to get into that because it's an automatic algorithm. But just to let you know that there's a barrier settings which you can modify to play around with the auto location of the annotations and dimensions. Now the last tab over here is the layout tab, and for this I need to actually go to the layout settings dialog box, which is not over here, and show you that in detail. But over here, all I want to say is that in the layout tab, you can choose a layout. And you can have multiple layouts. You can create as many layouts as you want in the layouts dialog box, which is elsewhere. And then you can select that from the assembly drawing settings. And what this basically, what is the purpose of having a layout is basically it tells the program for each page size. So you can have multiple page sizes like we discussed. You can have A1, A2, A3, A4, A0, 1, 2 A0s or whatever A size paper sizes you have. But for each page size or paper size, you can have a different set of material, whether you want the material list in that, whether you want the bolt list in that, whether you want a title block or which title block do you want and how do you want the title block to be located. So this is basically the layout of your drawing. What we mean by the layout is how the page will be laid out. So when consider this to be an empty page, you could have a material list at the top right corner, you could have a title block at the bottom, and you could have a bolt list just under the material list. And all these definitions would then comprise of the layout for that drawing, and we'll talk about the details of that layout when we get to this. But at the moment, all you need to know is that in the layout tab, you can select the layout which you want. Over here, we basically have several fields, and you can add custom fields over here. And whatever you fill, these fields can be then recalled into your title blocks, etc. And we'll talk about those in a second as well. So now that we've gone through all the major tabs from general to view to dimensions to annotations and display settings to the layout, now let me come back to the first one which we missed, which is multiple settings. And let's talk about that. So the first question which I want to answer is, why should we have multiple settings? I mean, don't we have a standard setting with which we want to draw our assemblies? But the answer is no. We normally we want to have different settings for different assemblies. So it's very typical to have a different settings for your vertical bracings and a different setting for your horizontal bracings and a different setting for your beams and a different setting for your columns and then maybe a different settings for your purlins and girts. You could have that in your company. And why would they be different? So maybe you want a different scale for the columns and beams because they're pretty big and they're pretty complicated. So you might want to draw them very cleanly with a larger scale, if you will. But when it comes to horizontal bracings, you might want a much smaller scale because they just have 2 bolts at the end. There's no need to draw them even at a 1 to 10 scale. You might even prefer a 1 to 20 scale on that. Similarly, the way you want them to be annotated might be different. So basically, every single field, you might want the scales to be different. You might not want to include single parts in some of your assemblies, but in some of your complicated assemblies, you might want to include them. Similarly, you might want different views to be taken for your girts and purlins, and you might want different views to be taken for your columns and beams. Similarly, your dimensioning styles you might want a different dimensioning style for certain members. Basically, I mean, the whole point is that typically it would depend on the type of assembly which you're doing, and your company might want different standards for those. So in COMOSYS, what we have is what we call multiple settings, and this is important to understand. So on the left-hand side, each row over here is basically a complete set of settings from the general tab to the view to the dimensions to the annotations to the layout. All these 1, 2, 3, 4, 5 tabs, the entire settings which you put in there, you can save that entire setting under one name over here. Every row over here is the complete settings of these 5 tabs. So I can create a setting called details of braces and save it away with this name. Then I can create another one called details of columns. I can create another one called details of beams and posts and crane beams and trusses, and as many as I want, basically. So on the left hand side, I basically create my groups of settings. And on the right hand side over here, I basically, so let me first of all create a new one over here to show you how that's done. So let me go over here and say add new row. I right click on that and I say add new row. And when I do that, a new one is created. And I can call this, let's call it my setting. And then what I can do is inside this, I can go and go to the general tab and say I don't want to include single parts. Let's say I want this particular view. I can change my scales to 5 for the main part and 12 for the assemblies and plates, let's say. When I do that, I can then maybe change something about the way the dimensions the way I want the annotation and displays to be. Maybe I want to change the layout. Once I'm satisfied with that, I'm going to say save to my settings, this one. And now this new setting has been created called my setting. Now the question is, where do we use this my setting? I've got details of trusses, stairs. Each one is different as far as these 5 tabs are concerned, or they can be different. But the question is, how do you tell COMOSYS when this setting will be used? And for that, we have this right-hand side. And what you do is you create once again, you can right-click and you can say add new row. And when you say add new row, it basically opens up a new row. And then you can say, if an assembly has a prefix of ABC, so basically this works by assembly prefixes. So you can have any more than one. So your vertical bracings might be called VB something. Your horizontal bracings might be called HP something. Your columns might be called CL. Your beams might be called B. So whatever your company standards are, let's say you have an assembly called ABC. And so you can have your assembly called ABC. And from over here, you can now select this my setting. So what this will tell the program is that if I were to create a assembly drawing, of an assembly which has an assembly prefix of ABC, then go and use the my setting, which is the group of settings for all these tabs. And this is very convenient because what you can do now is select the entire building. So select all your columns, all your beams, all your horizontal braces, all your vertical braces, all your whatever cranes and this and that, and they might all be having different requirements. And then you can just select the entire building, right click and say create drawings, and what it will do is it will go to each and every assembly, look at the assembly prefix, select the appropriate setting group from here, and create the assembly drawing according to that setting. So like I said, your horizontal bracings might be created in A4 sheets with only the horizontal bracing on one page, or as multi drawings on large A0s with 20 different ones. And your columns might be done as single assemblies, so one column per drawing. So basically, anything you can do with these 5 tabs, you can then save away as a setting, and that setting can then be used in a particular assembly. Now, to make it even more complicated, I should say, or even more useful from another angle, is that sometimes you have different styles of drawings. So what I mean, obviously, what I already said was a different style of drawing, but sometimes you have, so for example, one client might be asking for a particular style of drawings. So that client might be asking that draw my trusses like this, and draw my beams like this, and draw my columns like that, and draw my columns at this scale, and draw my beams at this scale. So you have an entire set of settings for a particular client, and then you have the entire set of settings for another client, or maybe you have the entire set of settings for one country, or the entire set of settings for another country where you might be working with, which you might be working with. So what you can do even more, even beyond this, so each row over here basically is represents the 5 tabs, and then on the right hand side you can connect that to an assembly. But then what you can do is you can connect this whole thing and give it a name and save it away. So you can, over here you can have things like drawings for America, for the American client, drawings for the Dubai client, drawings for the Singapore client, and you can save away those defaults. And what those defaults will be actually the entire group over here and the entire group over here, and the whole group will be saved away under one name. And then you can just, all you need to do is just go to your particular, let's say go to the my American client and say load, and the entire set for all your columns and your beams and your trusses and your vertical bracings and horizontal bracings, they will be recalled, and with a single click all your settings will be there. And now you can just select the building and press the create assembly drawing button. Now let me quickly create an assembly drawing using the settings, and then go over a few of the parameters just to show you how you modify the settings once you've created an assembly drawing. So let's select this beam over here. Let's right click and say select assembly and say show only. So this is what the assembly looks like basically. It's got a splice at one end. It's got so it's inclined, so it's got a curved inclined haunch at the other end, and then there are certain gusset plates, and there are purlin connections at the top. So it's reasonably I wouldn't say very complicated, but reasonably okay. And what we do is basically we select the assembly. You can select any part. You can even select a plate and say right click and create the assembly drawing. It doesn't really matter because it knows which is the main part. But let me just select the main part and say create assembly drawing. And when I do that, at that point, the assembly drawing is now created, and it's inside the drawings manager, as you know. If I double click on that, that drawing is over there. If you remember, this was the prefix 835156CE, and it started off from 1, so it's gone 001, the drawing number. And had I selected more than one beam, you would have seen, or they might have been in the same drawing. That would depend on whether you wanted multi drawings or single drawings. But let's just open this drawing for the moment and see what we have inside. So over here, let me zoom in. You can see it's a very clean drawing. Your purlin connections, your gusset connections have all been shown and very neatly dimensioned. If I move out a bit, your single parts are all very neatly dimensioned. This was the collapse which we were talking about, that the plates need, that the profiles can be collapsed, because this is obviously 7 meters long. It would make no sense to just give these end bolt numbers and then have this long thing going all the way over there with nothing on it. So you can obviously change those parameters if you want to, but these are the default values which it comes with. This is how plate has been dimensioned. This is how this plate has been dimensioned. You can see they're very, very clean drawings. Now, but what I want to show you right now is, obviously this has been created according to certain settings which we've been discussing in this video. Now, if I were to double click on anywhere in the drawing, somewhere over here, if I were to double click, there is this thing called macros over here. And in COMOSYS, whenever you have an automatically generated drawing, so what could that be? That could be a steel assembly drawing. It could be a steel single part drawing. It could be a concrete automatic rebar drawing or stuff like that. But like we know, there are GA drawings which are semi-automatic, and they're basically created manually with some powerful commands to help you out. But these assembly drawings are all completely automatic. So whenever you have a completely automatic drawing, you will, if you click on this macros button, you will see that the macro which has created this drawing over here. And if you were to double click on that, you would see that the same settings tab which we just talked about will open up. And you have, although it has what it has done is it has gone to the detail of beams because our assembly prefix in this case is B. So this line is telling me that if the assembly prefix is B or BE, so there's a space between the two. If it's B or BE, then use this setting, details of beam settings. And details of beam setting is over here, and we have all the 5 tabs. But let's say I don't want to spoil any one of those, but I just want to make some manual changes because I want to show you right now. So we can go on any one of these, make any changes, and basically press the execute button. And that's going to execute the macro again. And once again, the drawing will be created with the new setting. So for example, if I were to zoom in and see this plate over here, you can see we had talked about the dimensions will be created on the left side and on the right side and on the top and on the bottom. There was a setting for that, and then we had talked about a setting that how the parts on the assembly will be dimensioned. So if you notice over here, it has dimensioned according to both the edge of the part, as well as the bolt over here. So we can modify whether we want this. We talked about certain tolerances, that this plate might be cut at a bad tolerance, or this profile actually might this rolled profile might have a web thickness which is slightly smaller, or the length might be cut a bit. So if you dimension your part by bolts, it's usually a better practice. So let me just go in, double click on anywhere on the drawing, go to my macros, double click on the assembly macro and go to dimensions. And for the plates, for example, if I say for the left and right, I want only the right one, and for the above and below, I want only the above one, right? So if I do that and I say execute, and I press OK after that, and then I zoom in and I go to one of the plates, you will see that the right hand side and the top have been dimensioned, and on the left and bottom you only have the total dimensions, whereas previously you would have. Now it's not going to miss any dimensions. It's going to go basically it's collecting all the vertical dimensions on the right side and all the horizontal dimensions on the top side, and then it's only giving the totals on the others. But sometimes this might look worse, and you can change that back to, for example, if I were to double click on the macro again, go back to my dimensions and just leave it at default, which was the way it was, and say execute, and I go back into that one again, you can see that it has collected. This is the default behavior. You can have both. So the default behavior is above and below has a certain limit, and left and right have certain limits. So you can go and modify these numbers. Let's go and modify this parameter over here, which dimensions by according to bolts. And if I were to double click once again, go to my macros, go to my dimensioning, and say I don't want to dimension by bolts. I just want to dimension by parts. When I do that and I say execute, and say okay. Now if I go in, you see that this gusset plate, if I were to just pull this out a bit, this gusset plate has now been dimensioned by the edge only and not by the bolts. And similarly, this plate over here has also been dimensioned by the edge. Well, some plates will not have any bolts on them. So in those cases it will be forced to dimension them according to their edges, because if there is no bolt hole, then even if you want a bolt hole dimension, you can't create a bolt hole dimension if a bolt hole doesn't exist. But so in that case, it will revert to the edge dimensioning. So even if you went in there and you said, I only want by bolts and not by parts, but the part didn't have any bolt on it, so it would still revert to that. But if we were to say I want by bolts only and not by parts, then let's go back to that and zoom in once again, and now you see that your bolts have been dimensioned. Now, as to how many bolts will be dimensioned, usually one bolt is enough. So one bolt, but in some cases, if it's a skewed part, so there then two bolts might need to be dimensioned, and it will automatically choose that. Whether it needs to do 2 or more bolts to fit the exact part according to. So over here also you can see that this dimension also is basically doing it's connecting the bolts. And the reason why we have this line, you might think that this is not a bolt line, but the reason is because of this plate over here, because this plate doesn't have any bolt on it, so there is no bolt to dimension, so it's forced to give the edge dimension of the P414 in this case. So this is the way you can normally just double click on the created drawing, double click on the macro, and then go and change basically. And if you wanted to change the scale, you could change. Now, obviously, the right way to do it is to do this at the start. But what I'm trying to say over here is that you can modify individual drawings, so you can have all the beams created according to a certain rule, and then go and modify a particular one. You don't have to stick with that rule, or you can create a special rule for that particular beam. So you can have all beams starting with B will be the drawings will be created according to this rule, but you can give that particular beam a special mark. So let's call it the special beam, SPB, and the SPB will be dimensioned differently. So maybe the SPBs are very large beams and you want them to be dimensioned or drawn differently. What you can do in situations like that is basically create separate prefixes for those beams, and then basically hook up those prefixes with different drawing settings. So this is a very powerful way of dealing with your drawings in COMOSYS. So if I were to give another example, I could just double click once again and go into my macros and double click on the assembly macro, and from there I can go into the annotation and display settings. And for example, if I wanted my single parts of the plates to be drawn in a different color, I could go to the plate settings, go to the display, and maybe select, for example, I could select this pink over here and say OK. And if I wanted, instead of just giving the actual part number, if I wanted to, for example, include some other field as well, so I could maybe include the material field and say OK. And then if I went and said execute, then what would happen is that the plates would be drawn in pink, and the annotation of the plate would be the actual part number as well as the material. So the point being that you can even after creating a drawing, you can go in and modify the settings. Like I said, you can modify it, you can create different settings for different cases and save them away. It's a very comprehensive and complete way of dealing with drawings. Now, at the end, I just want to say that we had talked about the drawing settings for assembly and part drawings, but I don't need to basically show the part drawings separately because they're basically the same. If I were to open the part drawings settings, you would see that the same 5 tabs which we saw in the assembly drawings are available over here as well. Once again, you have control over your scales, your drawing titles, prefixes, etc. Views, the dimensioning options, how to dimension, the annotation and display options, and the layout option. The only thing which is missing over here is those multiple settings, which was to create for different settings for different types of assemblies. Since single parts are more or less the same, they're not different styles which are needed. So we don't have those multiple settings for the single parts. But otherwise, besides those, all the 5 tabs which you saw over there are more or less available over here for your use as well.